All right. Hello, everyone. My name is Margaret Mina-Reed. I'm the lead organizer of GDG Seattle, and I want to welcome you to I/O Extended, organized by GDG Seattle. As I said, I'm the lead organizer. We have quite a few other organizers here as well. There's Clive, and there's Inchi in the back recording, and then we have Balaji in the back doing the demo of the Edge TPU, and then Brandon is doing the check-in, etc. So we also have a few Googlers here to help out, give talks, and help with checking in as well. The first thing I want to start out with is the Code of Conduct of GDG Seattle. We are an inclusive community where developers, designers, and entrepreneurs of all skill levels, gender, religion, and backgrounds, everyone is welcome here. And if you see, our motto is be excellent to each other. If you see or experience anything that's different, please contact us, the organizers I just introduced to you. So we have a full agenda tonight. I'm very happy to see so many people here. We're kind of running out of chairs and food, etc. It's really great to see the enthusiasm here. So tonight we're gonna start out with a Flutter talk, and then we will move on to Kotlin, and then another talk on Angular, and then a talk on Linux apps on Chromebook. I will just talk briefly a few minutes about on-device machine learning, and then I will pass it on to Nivi to talk about machine learning and TensorFlow at I/O 2019. So I actually want to point out that throughout the event, you can feel free to, unless the speaker says so, like don't take picture. Otherwise, feel free to take pictures and put it on social media. If you do, use the hashtag IO19 extended or hashtag or the handle GDG Seattle, and just so that we get more of the festivity going on. So now the first talk, let's welcome Kevin Moore, product manager of Dart, to give us the talk, an intro to Dart via Flutter.
This is not my laptop, so hopefully I'll pick the right one here. Wait, no? Here we go. Testing 1, 2. Is that better? Can you guys hear me okay? Everyone in the back, thumbs up. So I was asked to give this talk, and so what I did was I took a 40-minute talk I gave at I/O 2 weeks ago, and I'm just going to go through it quickly and take some liberties on things. But you can see all the content with a much smarter engineer who works in the language team, Bob, on YouTube. So I encourage you guys to go look at the talk on YouTube. And there were a total of 5 sessions at I/O about Flutter and Dart. I am a product manager on the Dart team here at Google. And who's heard of Dart? Who's coded in Dart? Who's coded in Flutter? Okay, and real quick, iOS devs. Really? Android devs? Web devs? At least 2 of those things. Yeah, okay, hybrid. A lot of people do hybrid things. So one of the questions I get a lot, I've been on the Dart team for 5 years, before Flutter even existed, and a question we get frequently is, why did Flutter choose Dart? And so that was kind of the topic of the talk. Flutter, if you don't know, is a application toolkit for building beautiful apps across iOS and Android and other platforms, which I'll talk about a little bit if I have time. And it's it heavily bets on Dart. So at the low level, Flutter uses a C++ engine. It doesn't use the native widget library on the platform you're on. And so it uses Skia, which is the rendering engine in Chrome, and the Dart VM's baked in there, along with some tech support. And then the entire Flutter framework is written in Dart, the whole framework. So foundational pieces, the layout bits, theming, painting, UI handling, it's all written in Dart. And then of course, applications you write for Flutter are also written in Dart. So Flutter clearly made a deep investment here. Dart's not just a scripting layer on top. And so the talk we covered kind of 3 aspects that Dart aspires to give developers, that Flutter and Dart aspire to give developers. And I want to kind of touch on these really quickly. So those that don't know Dart, I want to give a very quick introduction. This is Dart code. And so there's no public static void main. I come from C#, so I'm used to a little more ceremony. So it tries to be a very low ceremony language. String literals, array literals, string comprehensions in strings, pretty straightforward. Classic OO things that you'd expect. So you can define classes, you extend classes, implement classes. There's a mixin concept, so that's the with thing, which is pretty cool. You can define variables, define methods. Nothing too surprising here, right? So again, if you're coming from JavaScript, Java, C#, Kotlin, C++, it should be really familiar to you. And then we have, what I consider more like functional pieces, right? So you can do array literals. We have things like map and join that you can combine on things, so that we kind of cover all the bases in terms of what people expect or like around modern languages. So I can do things like, add words together with a map, and then that creates an iterable. And so far you might have noticed hasn't been any typing, but we are a strongly typed language. So if you try to, if you annotate a method or a function, you'll get nice static errors at, before you run the thing, compile time, in your tools to say, you can't do that, it's a string. And of course we have generic support. There was a joke I wanted to do at I/O about how could you imagine Google creating a language that doesn't support generics to kind of thumb nose it. And if you know what I'm talking about, you can laugh. So you can do generic types, you can do generic methods. There's a shoe joke here about Reeboks. But this is kind of crazy and interesting, right? Like I can create a callback that goes from one type of a thing and convert it to another type. It's pretty flexible. And so all the things you expect from a modern OO language. And we have really strong inference. So this is kind of if you want to be really paranoid and write everything down, you can. But we can infer things, based on what you type. So you're passing in a string, so we know this is a box of string. You just do var here on the left. We know you're passing in num.parse, which is a thing that takes strings and turns them into numbers. So we can omit that. We can omit the type there, just do var here, and the right thing happens. So if I were to do string box.runtime type and print that, it would say box of string. So it's inferred. That kind of makes sense? So we try to do all the things. We try to be lightweight. Again, I tried to teach my dad C#, and it was like, okay, create a class, and then public static void main. That's like a semester of computer science in that one line, right? So we try to keep things simple, just entry point main. Obviously an OO language, which you'd expect. We try to do it in a relatively simple way, but straightforward. We have all the nice functional things you come to expect. So you can do map, where, chain those things together. You can do top-level members and things, which is pretty nice. And then we're strongly typed. So those 4 things. And so really quickly, I wanted to cover just, and I'll go really quickly through this, but some new features we've added to the language. So this is a build method you might see in Flutter. And you can imagine right now this is pretty straightforward, right? I can just do an array and do a literal there and find some things. If you don't get this now, watch the video, go play with Flutter, it'll make more sense. But as soon as you want to add some logic in here, right? Like if I say, oh, well, I actually want to see if it's not the last page, I'll do next, right? Suddenly I can't use that nice style. I have to jump and do this crazy stuff. And then if I want to add all the sections to the items, I have to do more stuff to kind of break out my logic. And so what we've added here, and this is another example if I want to do nested stuff, we added a new feature called, we're calling it UI as code. And so what it lets us do is you can just embed if statements there in your list literal. So I have a list literal, and I'm embedding in an if statement. So if that's true, and this is, this is not an imperative code, it's actually generating the list. See what's going on here? And if I wanted to add all the sections, I just do triple dot sections, and all the sections will just get filled out there. Or if I want to go for each section, and then do all the chapters and all the sections, I can just do this. So again, I have a list literal here, and we just added some features to make it really easy to do UI. Because you want to, and then again, if you know Flutter, it makes a little bit more sense. But all of the Flutter UI code is defined in Dart itself, which we think is really nice, because you don't have to learn a new language or anything else. And so what we're doing is we're adding features to the Dart language to support this model. And I can say as someone who does a lot of non-UI programming too, like creating args to pass into a subprocess, this is super nice. So here's an example. People yelled at us because there's more white space on the left than the right, but I still think it's more usable. So this is a new feature in Dart 2.3. So that's the language, but let's talk a little bit about the platform. Of course, at the bottom of the lexicon parser that turns Dart source code into an AST. In terms of runtime, we have something we call the CFE. So this is the engine that basically turns that parsed AST into something we call kernel. And kernel, you can kind of think of it like LLVM bytecode that has optimizations and type checking and everything else. And then we implement our backends on top of that. And I'll talk about that in a second. Then we have another stack of stuff here that basically handles stack analysis. So things on the left take valid Dart source code and turn it into kernel really fast. The things on the right can handle invalid Dart source code and give you squiggles and hints and refactoring, okay? And then your IDEs are based on that. So go to definitions, all that stuff. And so one of the benefits we try to offer, and I talked about this, so productivity side, we make sure we have good IDE support, a good language. We try to give you a fast experience, both dev time and runtime. So when you think about a fast dev experience, it's all around the Dart virtual machine. So all that yellow stuff I showed before, that's in the Dart VM, and we have a JIT compiler, debug services, a runtime. And so I'm going to start filling out a table here really quick. So here's Dart in the VM. We have this amazing support for hot reload. Has anyone heard of this? If you haven't done Dart yet and Flutter yet, you really look at this. So look, I'm changing the number here, and then I go and change the color in my IDE, and I just hit save. And my 10 stays 10. I don't have to reload the app. It just stays live, which is super. The first time you do this, it's amazing. And so imagine you're like in an app and you're like 15 levels down in some state in your app, and now you're going to change the color of the margins. You can just change the color in the margins, and you don't have to reload the app and re-navigate. And this works on your physical device, your dev device, or on your simulator. It just works. It's amazing. And so we can do this because of Dart. And because we maintain the whole system, we can split that front-end bit from the VM bits, run this on your dev machine, so we can create kernel files, be smart about how we handle the diffs and pass it over to the running simulator. And assuming you haven't renamed a class or added a field or something, we can do hot reload. And this makes your dev time super fast on Flutter. And this is kind of the power of Dart, at least what we think is pretty cool. We also have some really cool inspection services, so I can look at the visual tree. I mean, this is like what you get with Chrome, right? But you get this on iOS, Android, doing development in Dart. So you can inspect your margins and your layout, look through the visual tree, find out why things are laid out weird. But this is a native experience. So that's the Lightning Bolt. We have really cool development experience. We also do a bunch of work on performance. And so we actually compile down to native code, like ARM assembly, x86 assembly, or x64 assembler. And so it's not just like how fast do we run Delta Blue benchmark, right? We want to give you small code. We want to give you fast startup so the app loads quickly. We want to give you high throughput so you can get 60 frames per second reliably. And we want to make sure we have good latency, meaning we don't suddenly jank because there's a garbage collector. So we've done a bunch of work to deliver all of these things. And so you can get silky smooth at 60 FPS apps from a high-level language like Dart because we actually compile down to really optimized machine code. And so development, you use the Dart VM and JIT, and on the deploy side, you use AOT. And again, watch the talk for more details. I'm going fast. We're also multi-platform. So Dart has been supporting the web before Flutter even existed. In fact, one of our biggest apps is Google Ads. You might have heard that Google does a little bit of business in the advertising space. The thing that people use to buy ads on Google Search is completely written in Dart. It's actually a flavor of Angular called Angular Dart. And this is millions of lines of code, and it drives one of our most important businesses. So Dart does the web too, and very seriously. And so on the web, we have a great dev story called the Dev Compiler. And this supports fast reload, incremental compilations. You have a really fast development experience when you're doing web code. And then we actually are starting to work on things like hot reload. So that feature I showed you for native will also work on the web. We're not quite there yet, but we're working on it. We're pretty close. And then obviously when we compile to ship your app, we do kind of the same set of things we do on the native side. So we do full tree shaking and make sure we give you as small a JavaScript as possible, small, fast JavaScript. So we kind of have this optimized grid of things that does all the stuff. Now this is a lot of boxes for one engineering team to build, even with 60-some devs. And the way we do that is we have the front end. So we just finished a migration that gives us basically one code front end that handles a lot of that work. So those UI code features, the triple dot features I showed you, we actually are able to implement that for the most part in one spot, and then all the backends just get it. One thing that I've been working on a lot over the last year, we just passed our 1-year anniversary, is Flutter for Web. So if you haven't seen that, go check it out. And so how do you take Flutter and move it to the web? Well, it turns out we have all this Dart code here. We just slide out C++ bits and bring in the browser. And so we basically rewrote the shim layer, the lowest level rendering layer, and instead of using Skia, we wrote to Canvas and DOM APIs. And of course, the really funny thing is, if you're talking about Chrome, Skia is still there. So we basically had to go through some crazy kind of side tricks to get back to Skia, because it's under the hood in the beginning. But the output is this. So this is one of our friends, Reflectly. Which one of these is mobile? Which one of these is native mobile? Which one of these is web? Hint, there's a cursor on one. So the right one is the web. And I asked these guys, how long did it take you to migrate your code to run on the web? And he said 4 beers. So it was really quick. And so this idea of having one source space, you can do iOS, Android, and web, we're pretty excited about. And so check out that stuff there, flutter.dev/web. I work on this stuff. It's super exciting. And we run a bunch of other places. So we announced some stuff on Chrome OS, Google Home Hub. People have it running on Raspberry Pi, CLI, Cloud. The SAS package, if any of you guys do Node, you guys know Node? Anyone use SAS for like JavaScript stuff? That is sourced in Dart and then compiled to run on Node. It's really crazy. So we run a bunch of cool places. And those are the 3 things. There's some future stuff that I have to go through really quickly because I'm running out of time. We are doing work to support non-nullable types, which people have really asked for. And so basically we're adding question mark here. You can't call is even on null. Try parse will give you null if it's not an integer. And so we're actually adding question mark. And so you'll get this as a static error, and you can actually wrap the null check, and then we'll be smart and say, oh, you've done a null check. I know is even is safe there. And so we do some inference stuff that's really nice. And so we're super excited to add this to the language. It should be coming soon. What's cool is we're doing work to make sure it's incremental, which we think is important. So you can migrate your code incrementally, add some tools for that. It's going to be fully sound, which is actually one of the biggest selling points for me. Not to point fingers at the next person talking, but there's lots of people who build languages and systems that build on the JavaScript ecosystem. We know some. Or on the Java ecosystem, which is great because you don't have to reboot the world. We kind of started from scratch. But the nice thing is we can make decisions deeply in the system. For instance, make sure non-nullability is deep in the runtime, which gives you not only fully soundness, like provably mathematically sound, but we can actually optimize around it because we know that the whole system supports non-nullability. So we're really excited to be working on this year. We're working on a bunch of other stuff, extension methods, new concurrency things, foreign function interface improvements. It's a fun time to be Dart. We're aware of people coming from other languages and want other features and a bunch of other stuff. If you're curious about what we're doing in the language, that's the repo for Dart, and then the language stuff's there. We just launched a new website, dart.dev. We'd love you to come take a look at that. It describes all the things we're doing. And that's me with 45 seconds left. So dart.dev and flutter.dev if you're curious. And I have 45 seconds for 1 or 2 questions. I might be around. We'll see when the babysitter expires, but at the end. Any quick questions? I know that was fast. Go to the Flutter. There's a Flutter channel on YouTube. You can see the 5 talks we had at I.O. Find us on these websites. Any kind of quick, non-overly existential questions? Sir?
Does it work on Android only, not iOS?
Android and iOS. On the simulator or on an actual physical device. It's pretty nice. And on the web. It's kind of magical. Sir?
Do you guys have your own IDE or?
We do plugins for VS Code, all the JetBrains IDEs. We're working on the common language specification protocol thing. So like someone has like VI and Emacs working too, but VS Code and JetBrains are kind of our big ones. And we're done. I'm Kevin Moore. I'm KevMoo. Everywhere. Thank you. And next up, Kotlin.
Are the code labs still up?
Oh yeah.
Yeah.
The code labs are up. Actually, what's crazy is the Flutter code labs now. I'm waiting for him to get up here. You can find the slides. I'm so happy with the Flutter web stuff. You can now do the Flutter code labs in a web browser because it's all web-based. So I'm cocky because people obviously really care about native mobile. That's great. But I'm like, no. But their first experience with Flutter will be web because you can actually do the code lab in a browser. It's like and it renders, and it's pretty cool. Here we go.
Okay, next up we have Nate that will be talking about Kotlin. Here we go.
Thank you. Okay. Is this on? Yeah? Yeah. All right. Haven't had a mic in a while. You can't hear it up here. Hi. My name is Nate Ebel. I'm an Android developer at a small company called Pixite. And as you can probably tell, I'm going to be talking a little bit about what's new in Kotlin. And so we're going to be looking at some of the new features that have been coming down the pipe over the last few months, and then we'll look at some of the latest and greatest that was discussed at Google I.O. a couple weeks ago. And then we're going to kind of wrap up with looking at a couple resources that you can use to learn more about Kotlin going on later this year. And so I'll just call out that I'm going to be pointing to a lot of resources like blog posts and Google I.O. talks. And so I have the slides up on Twitter or SpeakerDeck, and all those links are in there. And with that, we'll jump in. So I'm going to look at some of the new features. Specifically, so far this year, we've had multiple kind of point releases of Kotlin. We've had 1.3.2, 1.3.3, And those are really building on a lot of the stuff that came in 1.3, not surprisingly. So we have a lot of stuff coming with like coroutines, a lot of tooling improvements. So we're going to look at a couple of these specifically. So we have coroutines and then flow. We have the new Kotlin X serialization library. And then we'll list off just a few more things towards the end. So we'll start with coroutines. So these really went live with, I think, 1.3 was their stable version. And if you're not familiar with coroutines, it's kind of the Kotlin idiomatic way now of writing asynchronous, non-blocking code. Now, coroutines are not a new thing. They've been around for, I think, 50 or 60 years at this point, but they're coming kind of back into popularity within like the last 10 years or so. And so Kotlin is really just borrowing and replicating a lot of the patterns you've seen in other languages, C#, JavaScript, other areas. And so all of this work is really living in the Kotlin X coroutines package. And by default, the language is just providing several kind of low-level primitives. And then other things like the Android framework, other libraries can then build on top of those for whatever specific use cases they have. So we'll look at a couple of those, but one just example here to call out, which was, I think, new as of I/O, is a view model scope in Android architecture components, which is a nice convenient way of being able to use and launch and clean up your coroutines in kind of a standard way. So if you're not familiar, this is a basic example of coroutines taken from kind of their documentation. You notice a couple of the primitives here, like run blocking, launch. We have the suspend keyword that lets us denote that we have a suspending function. So we can then run this inside a coroutine in such a way that it's not going to block whatever kind of thread or context that it is called from, which lets us write a function like this, where we can say launch do world, which is something that is going to delay. And instead of blocking the thread, because it's in a coroutine, it's just going to suspend this coroutine. So we can go on and do our other work. And then once that coroutine is done, it'll kind of return back. So in this case, even though if we were doing this in a very imperative way, it might look like world is going to get printed out first, we'll actually get hello world printed out to the console. So this is just a very simple example of what you can do with coroutines. Now, within the Android space, coroutines have been supported for a while now, but as of Google I/O, I believe the support for a view model scope within the architecture component view model class is finally live. So before, you used to have to do a little bit of your own work to manually keep track of all these different coroutines that you might be launching, and then you had to make sure that they got cleaned up, because if you had anything running that was resource heavy and you didn't properly clean it up, you might leak those resources, which we don't want to do. So now the team has taken care of that for us, and it's really easy to launch these coroutines and do this work in the background. And so the first talk I'm going to point out is this Understand Kotlin Coroutines on Android talk from I/O. If you are unfamiliar with coroutines or you're starting to use them in your Android projects, I highly recommend this talk. The next thing I want to look at is Flow. Now, Flow is a pretty new project here, and it's really built on the work that has been coming out of coroutines. And so Flow is essentially a library for doing asynchronous cold streams with Kotlin. So if you're familiar with RxJava or any of the other ReactiveX implementations, that might sound familiar to you. In theory, in the Rx world, you have kind of hot streams and cold streams. And now in Kotlin for a while, now we've had kind of the example of hot streams with coroutine channels. So Flow is essentially the work to kind of complete that Rx symmetry by bringing the cold streams to it. And with that then comes things like filter, fold, and map that let you kind of transform your data in a very functional fashion. And the really, really cool thing, at least I think it's really cool, is that Flow works in a multi-platform way. So there's a lot of work ongoing still with Kotlin multi-platform to be able to write a lot of code and share that between iOS, mobile, and other targets as well. Excuse me, iOS and Android and other targets. And so this lets you sort of have that kind of reactive hot streams and cold streams all in a Kotlin idiomatic fashion without having to worry about anything like RxJava, which wouldn't work in a Kotlin only project. And so just a quick example of what this looks like. You can define a flow like you have there at the top. And then this is essentially going to go through and iterate 10 times, and each time it's going to delay for 100 milliseconds, and then it's going to emit that item. Now down below we see we have this collect call. Essentially what will happen with a flow is that terminal operator, in this case collect, is going to collect all of the things emitted by the flow, and then we can operate on those. So in this case we're printing those out. We could map these, we could transform them in any way, but at this point it looks very, very similar to kind of the reactive world that you might be familiar with RxJava or any of those like libraries. And all of this is built on coroutines. So it's really a fully Kotlin idiomatic way of going about all of this. Another thing that I want to just talk about briefly is Kotlin X serialization. Now this was kind of talked about a little bit in passing at I/O. It's been around for a while, but it's another really cool sort of Kotlin multi-platform supported way of serializing and deserializing your data. So this is an example here where you can see that we have a data class here, and we've annotated that with a serializable annotation. And now with the Kotlin X serialization library, we can call data.serializer, which is a compiler-generated serializer for us, and we can use that then to either parse or write out the JSON for that data class. So this is really simple, and it's something supported by kind of the platform itself, so we don't have to turn to third-party solutions, which means it's also available today in the Kotlin multi-platform project. And like I said, there's been a lot of changes going on. Incremental annotation processor support in Capt, unsigned numbers, CocoaPod support for Xcode if you're doing Kotlin native projects, the Kotlin Gradle DSL is now supported for Kotlin multi-platform, a lot of tooling updates. Really a lot of work is going into making Kotlin work really well, not just in Android where it's been traditionally, but also across different targets and projects as well. So, look at a little bit at what was going on with Kotlin at I/O. So the biggest thing there was kind of this idea of Kotlin first now for Android development. And I was curious when I heard this what that meant, because for 2 years now they've been pushing Kotlin alongside of the other languages and really saying that there's going to be support for all 3 supported languages. And so their kind of definition, I think, of what Kotlin first was taken from one of these, or from this slide at one of the talks. So starting to see, and they were talking about this at I/O, more features and APIs being designed with Kotlin in mind from the get-go, not just in the KTX library, but across a lot of the Jetpack libraries as well. So these are things like coroutines or the new Jetpack Compose library, which we'll talk about. So the first place we're seeing a lot of this then is in the architecture components, which they've been iterating on now for a couple years. So I really liked this slide, which I think kind of illustrates that very well. See, pretty much in every architecture component here, we have some type of support now for Kotlin. So coroutine worker in the work manager, suspending functions in retrofit and room. We're starting to see that we can start to implement these different patterns like coroutines in anywhere in our application using the architecture components. Another thing I was really impressed by is that we have coroutine testing support already as well. So it's nice to see testing support kind of as a first-class citizen. Now, possibly the biggest announcement on the Android side at I/O, or at least the one that got a lot of the buzz, was Jetpack Compose. Now, if you haven't heard of this already or you're not quite sure what it is, Jetpack Compose is essentially a new UI toolkit that the Android team is working on. It's really modeled after things like Flutter or React Native. So actually the code we saw in the previous talk is going to look really similar to one of the examples I'll have in one of the upcoming slides. And another of the really interesting things about the Jetpack Compose project is that it will be unbundled from the framework. So the team is taking the same approach that they have with Jetpack and kind of the support libraries as a whole, and building this new toolkit that can then be shipped faster and iterated on without having to worry about kind of your min API catching up to whatever release a certain UI bug fix was in. And the Compose project is really 2 main things. It's kind of this UI library, which are all the new kind of components and widgets. and then a Compose compiler that honestly is a little bit black magic still at this moment, but essentially behind the scenes, it is generating the code for us that knows how to take in the state, do all the diffing, and give you efficient rendering and UI updates. So here's an example from some of the kind of samples and documentation out right now. But basically what Compose will allow us to do is write declarative UIs by creating these functions and annotating them with the composable annotation. Within that, you can then build up new UI elements. In this case, we can see text and button are being added, and then you can set those properties on them. You'll also notice there within the counter function, we have this plus memo and then a counter state. So you can add state elements where they will be remembered and then diffed when you pass in new information to this. So they're really trying to support the idea of a unidirectional data flow with this new UI system. It's also worth noting that, so we see here we have text and button, which we have kind of corollaries with in the existing UI toolkit, but the Compose versions are going to be new and different. The UI will be compatible with the old UI toolkit, but they're going to be kind of working from scratch to try and get away and implement some of the lessons learned. So for example here, if we have an activity, we could still set kind of our top level component in there, and then call set content, and then from there the rest of the UI can all be done with Compose. So that's really interesting, very cool. Small disclaimer, actually a pretty big disclaimer, but this is still pre-alpha, so it's available in AOSP right now, and you can download and build a project. You need a special version of Android Studio to run it, but they are very actively encouraging comments and participation. So if you're interested in that, or if you really like what is being done on, say, like Flutter, and you want to see that improve on native Android, give that a shot. And so like I mentioned, just a few notable talks related to Kotlin from I/O. Like I said, understand Kotlin coroutines on Android, mobile backends with Kotlin and Google Cloud. This is really interesting if you're curious about using Kotlin for sort of backend services. I think they stand up 2 services using Ktor and Google Cloud within the span of about 30 minutes. It was very interesting. They went really fast, so I encourage you to check that out. Kotlin under the hood was a really interesting talk. Declarative UI patterns, that's the Compose talk. Really worth going in and looking that talk. Even if you're not that interested in Compose, it's interesting because they kind of went into a history of the existing UI toolkit and some of the challenges associated. And then finally, what's new in Kotlin, basically a better, longer version of what I'm giving you right now. And so finally, a couple new learning opportunities coming down the pipe. They announced a new Developing Android Apps with Kotlin by Google course. So this is with Udacity. It's a free course. If you already are a little bit familiar with Kotlin, this is a really good way to expand that learning and go in and see kind of the new recommended best practices using the architecture components and how to build an Android app. And then the last one, which is really cool, is the Kotlin Everywhere initiative. JetBrains and Google are collaborating to launch community-driven events around learning about Kotlin for mobile, multi-platform, web. So you can basically apply to sort of have one of these events and get some support from Google and JetBrains. If you go through that, they will give you kind of a little toolkit. They'll help recommend things for like swag, marketing resources, finding speakers from the developer community. I know we have an event already in the works here in Seattle, but I'm sure we could have more. So if you're interested, you can check out the Kotlin Everywhere resources. And that's it. Like I mentioned, we have a bunch of posts and stuff here all related to some of this stuff, and the slides are pinned at the top of my Twitter account if you want to check them out. And that's it. Thank you.
Hello. Hello. Should we get started?
Yep, go ahead.
Okay. Hi, my name is Mike Moreland. So I was not at Google I/O, but in the Angular community, we had our biggest conference just the week before Angular I/O. So it's called AnyConf, held in Salt Lake City, Utah every year. So first of all, this part of this presentation was still at I/O and was held by Stephen Fluen. Brad Green and Misko and Igor had a similar presentation at AnyConf. So big thanks for them for creating at least half of these slides. So first of all, Angular's core values. It's all about the users, developers, and community. So it's about creating applications that users love to use and applications that developers love to build. Sorry for this, it's the wrong transition. And a community where everyone feels welcome. And it's something you'll hear all over if you go to Google I/O or AnyConf. So the Angular community has been growing a lot during the last year. It's been growing about 50%. So you can see it's now, they're measuring 1.5 million users. And the way they do this is they measure how many that goes to the documents at angular.io. So track that over a period of 30 days, see how many unique people that go there, and that's how we got to 1.5 million of these numbers. So how many here have used Angular? About half the people. We're going to convert a few more tonight, if this goes well. But so in Seattle, we also have an Angular community, and we meet in this room as well, so you're welcome to join us. So these are the Angular products. It keeps growing every year. Don't have time to talk about all of them, but we're going to mention the big one that came out last year was Elements. So what Elements is that you can now create a custom element that's a web component that you could then reuse anywhere you have HTML. Whether it's just plain HTML, it's just a JavaScript import. So you could use it together with React. If you build component inside of Angular, reuse it now everywhere. Of course, Angular was at the time larger last year than it is today. We'll get back to that. The other big one was a lot of things happened inside the CLI last year. And I also want to mention Protractor. Do we have anyone from the Protractor team here? He's waving behind you. So Protractor is Seattle, that's why I'm giving them a shout out. So with Angular 8 and up to 8, they've been working a lot to make all these upgrades frictionless. So what that means is you can actually take a command and do the upgrade yourself. When you went to like version 2 to 4, it could take you days to do that upgrade. Now you'll do it sometimes only in a few minutes, depending on how big the application is. And the way they get this to work is because inside Google they have over 900 Angular applications. So they're always on the last version of Angular. So it means when they come out with 8 and do upgrade from 7 to 8, they also use these commands and upgrade all the internal version from 7 to 8. So they've gone through and found all those problems with upgrades, so that should cover a majority of all your use cases. So it's pretty slick. So I mentioned we are now on the release candidate for 8, and 8 is coming with a bunch of more features. The one I'm really waiting for is lazy loading via import. So today you do lazy loading when you route to something. In the future you could actually do lazy loading on command. You could do it on hover, you could programmatically do it when you want, and in the future you can also lazy load Angular itself. So you can split everything up in much smaller components. But there's a bunch of other new stuff too. So the way you try out the new Ivy in Angular is just by adding this enable Ivy. And I should mention, there's a Twitter contest tonight. Anyone that want to tweet about this, take a picture, you have a chance to win this cube from AnyConf. So Angular upgraded twice a year, and they're releasing version 8 final any day now, and then in Q4 we'll see version 9. And the reason I'm mentioning version 9 is because now the new renderer is more of an opt-in. You can play around with it, but in 9 it should be by default and fully backwards compatible. So why we care about the new Ivy render is because everything's going to be smaller, and that makes everything faster, and it makes also things easier to debug. You could actually do debugging inside of HTML. Set your breakpoint inside HTML, and your code will stop right there. So with Vue Engine, that's version 7. You can see it's create an application. It's about 150K. In 8, it's going to be about 100. In 9, it's going to be a lot smaller, as you can see. So these are the things you get now in 8, and then 9, you're going to see it's going to get a lot smaller, which also makes it going to be a lot faster to compile, just because it's smaller. So another cool thing at AnyConf and I/O was Stack Blitz. So let's see if I can get to. So the reason I'm mentioning Stack Blitz here, you can create a new application. You can create an Angular application. You could use anything else. If you want to use something like Flux, play around with that, RxJS. And I have 3 minutes for this demonstration, and I'm going to make it. So we're going to start up an Angular application. What that means, it's about 1,000 libraries we need to download from NPM, and that shouldn't take too long, right? It's actually already done, up and running in your browser. You can go to this URL and see this right now. And you heard a thing like hot reloading that we have. Guess what? We have it today as well. If we, sorry, the text is kind of small here. Angular 9. You can see hot reloading. It's updating right there. And if I was on my computer right now, on the side here, this little button here, you recognize it says it's a Firebase button. You click on that. If I was signed in, you would see a Firebase project. Just click deploy. Another 30 seconds later, this application is on Firebase. Pretty cool. And the last thing is deploy to space, play around with it. You can actually deploy your website to space, but you have to do it in the next 9 days if you want to be in space. So last slide, these are the guy behind Stack Blitz. Eric and Albert created company. I highly recommend to go to AnyConf or Google I/O. You'll meet lots of interesting people. And my final slide, I'm Mike. You can find me on Twitter, Mike_BeastCode. And I'm one of the co-organizers at Angular Seattle. You can also find me there, and Craig. Any questions for 30 seconds? Good.
Hi everybody. So this is Clive and Greg here, and so we're going to talk about a little bit about Linux on Chromebooks. So this was one of the smaller sessions at Google I/O, and but we're excited about it because we actually have a machine here that's actually running Linux on Chromebooks, Linux apps. And so this is what we're going to talk about. Let's see if we can, if that's clear. Okay. We're struggling a little bit because it's kind of works a little bit differently. So we're going to talk about a little bit of an overview of Chromebooks, the biggest feature since Android apps. So we can now run Android apps on Linux, which is also known as cross-teaming. And we're going to give a little demo and talk a little bit about security and then some recommended Chromebooks for Linux apps, which Google's recently updated. So the session at Google I/O was really titled Linux for Chromebooks Secure Development, and warning, mind shift ahead. So the thing that's going on with it's kind of important to understand a little bit of a backdrop about computer security. There's a whole bunch of flaws that have been discovered in modern processors, and particularly x86 processors. And so the operating system that you run needs to now do some additional work for you. Unfortunately, Chromebooks actually does that. I think so does Android. And anyway, so we're going to take a little look at that. Where this came from was originally, for a long time now. In fact, I've run this for probably at least like five, maybe 7 years. I ran Crouton. In other words, I ran sort of I got a bash prompt on my Chromebook by almost doing a dual boot. It's not exactly a dual boot, but it was basically running Chrome and a Linux on side by side. But now Chromebooks has turned that around, and we actually have the ability, it's called Crostini, to actually run Linux apps on Linux. Think about it like it's very similar to the Android architecture. And having said that, this is kind of what the stack looks like. And so we got our Chromebook hardware that we're running, and then we've got our firmware that the manufacturers provide, and then we've got the Linux kernel. This is where it gets a little bit specific, and especially if you're planning on buying a new laptop, perhaps because you don't use, you do a lot of web development, and you'd be fine with a Chromebook, and you don't need a MacBook. You need to be really running a Chromebook that runs the latest Linux kernel, and I provided a link to that further on in the slides. And then we've got the Chromium, the whole Chromium project, and the Chromium project supports Chrome OS, which has been around for 10 years or so for now, and along with the browser. And then about 2 years ago, Google added the Android apps, so you can now have the you can now have Android apps and access Google Play on your Chromebook. And this is really cool because if you need to have an Android dev system and you want to have it on your Chromebook for some reason and test out the tablet mode and all sorts of other things, you can actually do that on your Chromebook. And then what Google's gone and done is added, they've had Crouton for a while. This runs inside as a host Linux terminal, but Crostini allows Linux apps and to run as a guest inside a VM. So this is kind of a little bit like a Docker container. I think that's the way I like to think about it. There is the link I provided earlier on in this slide deck. There's a specific talk where the lead at Google talks about quite a bit of the security without getting too much into the details, because there's a heck of a lot. And then our next slide is, oh my God, demo time. So Greg, fine man, is going to show us a little bit what a Linux app looks like on a Chromebook.
So I'm going to have to boot up that app, which is in the Linux apps, and it's just Kate, which is a KDE editor.
So I should tell you here that Greg and I both have a Samsung Chromebook, and Greg has the
this is the Plus.
He has the Plus.
which is an ARM processor.
Yeah.
It has a later version of the kernel, the Linux kernel.
I have the Samsung Chromebook Pro that has the earlier version of the Linux kernel, and Linux apps don't work on it yet because it's running Skylake, which is not very recommended for Linux apps on Chromebooks. In fact, it's not recommended at all.
So there you have. This is a Linux app of Kate running inside of Chrome.
So I think you can see here that Greg didn't have to do any like dual boots or anything. He just launched the app as if it's just running on Chrome, and it's kind of like seamless, the experience there. And what's nice about it is this is kind of running inside a container. So if this is a dev machine and the dev needs to toast this because it's like got bad symlinks in and so forth, you just toast this container and install another one, and you're good to go. So you haven't contaminated your machine or picked up any security flaws. So can we switch back to the slides, thanks? Okay, so just a couple other things to do here. I mentioned that the Chromebooks are actually excellent to deal with this zombie load attack. In fact, as soon as this attack was announced, Chrome disabled the hyper-threading in Chromebooks, which was important for security. And this is something from Google Security. This is actually how this flaw actually works. If on, say, a MacBook or a Windows machine or a Chromebook prior to this being disabled. And this you can actually do this in code by coding up what's called an ES membrane. Salesforce has all of their apps, mobile apps, running using this technique, using the GDGSea shim. But this kind of like needs almost rocket science type development knowledge to do. So I prefer to use Chromebooks because on Chrome I can basically make myself a secure dev environment without needing to tackle this. This is the list of recommended Chromebooks for Linux apps at this time. This keeps changing. There's a link here that links to these. So it's actually these 5 Chromebooks. And what's important about this is notice that the Pixel Slate isn't in this. Usually Pixel Slate's always the recommended machine, but these 5 machines use the Y series processor, not the U series. So if you're going to go out and buy a machine today and you want it to be like just as best as possible for doing group development on Chrome, these are the 5 machines at this time. But that doesn't mean that your machine doesn't run. You can actually check that on this link down here, and it'll actually tell you, does my machine work? And lastly, why would you do this? Android Studio, there's a new version coming which is going to be really easy to install on Chrome OS, and that's already in beta. And Chrome OS 76 is going to even enable GPU acceleration for Linux on Chromebooks, so that's going to help anybody that's doing machine learning. So I think we're out of time, but thank you very much.
Thank you, Craig and Clive. So, as I introduced myself earlier, I'm Margaret, the lead organizer of GDG Seattle. I'm also a machine learning GDE, a Google developer expert for machine learning. So I'm going to spend the next few minutes to share with you my experience attending I/O. The best part about attending Google I/O in person is to meet the people. The night before I/O, I get to go to 3 parties. The first one, I had dinner with all the machine learning GDEs. So it was really fun. And then I went to the second party, which is Women Tech Makers dinner. And Nivi, you were there. And then I ran to the third party. I do Android development, so I still love the Android community. So I ran to this Android party there, where I think Nate was there, Inchi was there as well, and got a bunch of pictures with a group of women. At I.O., I played ping pong. I love playing ping pong. That was really, really fun. I played ping pong with a bunch of GDs as well as Martin right there. I taught Martin. For those of you who know Martin Omander, I was teaching him how the rules of ping pong. And Wednesday afternoon, which is the second day of I.O., I got invited to a Google Cloud VIP reception where all the machine learning GDEs and the cloud GDEs got invited to chat with the Google Cloud platform team. I felt very important going to that VIP getting together. So how many of you know TensorFlow 2.0 using alpha is going to release soon? Some of you. Anyway, so we're trying to improve the documentation of TensorFlow 2.0. So I'm leading the worldwide doc sprint with like 60 organizers. At I.O., a couple of us got together just to discuss our planning. And then in the evening, I attended the AI and the machine learning meetup with Jeff Dean, who's the head of Google AI, and then the Google Brain team, which is really fun. Now I'm going to switch to the topics about machine learning, what I learned. So after my talk, I'm going to go really quick. Nivi is going to go into more details about her learning. So mine is basically pointing you to the resources, right? So I won't go into the more details, but you can find me if you have questions. I'm going to focus on my learnings in 3 areas from I.O. First is on-device machine learning. I've been to I.O. since 2015, and every year I was paying attention to the machine learning part. This is the year really there's like 5 or 6 sessions of on-device machine learning, and Google is really trying hard to make machine learning, on-device machine learning easier. So here is a list of the talks that I recommend you go to watch. The first one is machine learning on your devices, because there's different options there. Lawrence Moroney and Daniel from Google gave a talk on that, and they walked through the code for you to do machine learning on Android, machine learning on iOS, and machine learning JavaScript as well. And then second one is what's new with Android machine learning over there. And then we have AI for mobile and IoT devices. This is focusing on how TensorFlow Lite works. How do you get started? How do you actually go about using the converter? How do you do optimization, etc., etc. And then another talk is machine ML Kit for mobile with Firebase. I want to tell you about 3 features about ML Kit. Very exciting. One is the object tracking, detection and tracking. Second one is translation. You can use ML Kit to do translation on device for 56 languages, I believe, without the network, on-device machine learning. And then the third one is the AutoML integration with, you can do the AutoML training through MLKit, and then take that TF Lite model and put it on your device. And then there's another talk is built on-device AI with Google Corral. Balaji in the back there, he actually has a demo, after all the talks, if you want to actually look at the Edge TPU, how it works. All the models that's running, you can use a phone or you can use your Raspberry Pi, right? But it's not going to be as fast for the inference. The Edge TPU actually running the inference on the TPU, which is really fast, even faster than the GPU. And then Intro to Camera X Jetpack library. How many of you are Android developers here? Quite a few of you. And you know the pain of using that Camera 2 API. Almost 1,000 of the lines, right? So this is super important. When you use machine learning on device, you need input image when you do computer vision, and then you need to rely on that camera. So Android devs, super excited about that. And then I summarize all my learnings for on-device machine learning in the sketch notes, and I put it on Twitter here. Now, the second category I want to talk about is get started with machine learning. How many of you are new to machine learning and you want to learn? Quite a few of you. So there's 3 talks here. I'm not going to read through them, but you can go read them, watch them later. All the I/O sessions are recorded. And then if you're getting started, I highly recommend those 3. Then the third category I want to talk about is advanced and the future machine learning. Highly recommend Swift for TensorFlow. Watch that one because it was a really next generation framework, TensorFlow framework. Federated Learning is also interesting. And then the cutting edge TensorFlow new techniques is interesting. One thing I think there's like a keras tuner, something like that. So automatic hyperparameter tuning. So that one is super interesting. There's a couple other techniques in there as well. You can watch the video. And then TensorFlow Extended is more of the end-to-end pipeline. Deep learning to solve challenging problems, and Jeff Dean basically walk through, some of the problems that you can solve with deep learning. There are a bunch of collabs, and Martin Gorner, who's from Google Cloud team, wrote 4 collabs to help people get started with deep learning on TPU, which is really nice. And here I also included a link where you can see all the collabs from Google I/O, which is pretty interesting. Now, as I mentioned earlier, attending the conference in person is really to meet the people, right? And another thing interesting is the demo and the sandbox. So I want to play this really quick for you. Okay, so that was me dancing there. Looks like I'm dancing like a pro, right? And some of you probably, if you already know machine learning, when I first looked at this app, I was thinking about the Everybody Dance Now, the one where you actually transfer the style of dance to another one. Well, this one is not so much of a transferring the style. It's actually me dancing, but they actually will compare the pose and the body segmentation, and then they also use time warping to speed up my movement, so make it look like I'm dancing like a pro. So I thought that was super interesting. I listed just a few sessions above, and there's so many other great talks there, and I have listed you can watch all the I/O sessions and all the TensorFlow sessions. All right, so that's my learning from I/O, and thank you. And next up, please welcome Levi to give you a talk on TensorFlow.
So can you folks hear me all right? Okay, cool. So hi everyone, thank you so much for staying. I know things stand out a little longer than we anticipated. Appreciate it. So my name is Nivi. I am a second-year PhD student at University of Washington, Seattle. I work in the biorobotics lab with Professor Blake Hannaford. My research is at the intersection of medicine and robotics and computer vision. So I work in the field of surgical robotics, so it's basically tying in medicine to robotics. Cool. So just a little bit of an overview. This was my first I/O, so if I sound extremely excited about some of the things, it's because it was pretty fantastic. It was my very first I/O. It was incredible. I absolutely loved it. So I'll just take you through some of the things that I found interesting at I/O this year. So for those of you who've been waiting to hear a little bit more about TensorFlow, I am not going to deep dive into the things that people spoke about because the talks are available online. But what I'm going to talk about are the things that people didn't talk about at the TensorFlow Dev Summit, and so things that changed between the Dev Summit and I/O. So those are basically updates that have happened in the TensorFlow community, but for TensorFlow 2.0, and I included that because if there are people who are not familiar with TensorFlow or machine learning in general, I just wanted to give you an insight into how you can kind of get started, and TensorFlow 2.0 is the next nice thing that's coming out of Google, so yeah, I recommend you check it out. So just getting started. Like I said, my very first I/O, I met a ton of really, really, really cool people. So these are people that I've looked at on stage for a very long time. I think I almost couldn't breathe when I was again next to Jeff Dean again. So I met him for the very first time last year at the TensorFlow Dev Summit. And this year, meeting him again was incredible. And I got to meet Astro Teller from Google X and a bunch of really cool people from the TensorFlow and Google Brain teams. So yeah, it was a huge fangirl moment. And we also got to hear from Geoffrey Hinton. So that was amazing. So for those of you who are not familiar with the deep learning space, Geoffrey Hinton just won the Turing Award because he persisted when a lot of people basically gave up on neural nets some 30 to 40 years ago. So yeah, a lot of really cool learnings when I was there at my very first I/O. All right, so just a show of hands, how many of you watched the Google I/O keynote? All right, a good number of you. So one of the projects that I really liked as a computer vision researcher was something that, on Google Lens. So Google Lens is basically like a smart vision capability integrated into your camera. And now there is like an extensive set of functionalities that they've incorporated into Google Lens. So in addition to just being able to translate documents, you can now point your camera at a pamphlet. It can translate in place what you look at in the documents, and then it can read out what it is translating with context. So, and all of this happens right on your device, right? So for those of you who probably heard like machine learning needs a lot of compute, you can imagine how much of a big deal this is when you're able to run all of this directly on your mobile phone. Right, so that was incredible. And one thing that that was like a pretty cool update, in my opinion, was the dining option that's been incorporated into Google Lens now. So instead of you having to like navigate between different apps and trying to figure out what is a good, food option or menu option that you can pick out at a certain restaurant, you can basically just take your phone, point it to the menu at the restaurant. It will highlight what are the recommended food items on the menu. And in addition to that, when you tap on it, it'll show you pictures of that menu item and show you related reviews for that particular dish. So this is a functionality, again, that's all been incorporated into Google Lens, and you can do all of this right from your device. So it's pretty incredible what's happening in, like combining mobile development and machine learning altogether. The other thing that we saw a lot of was speech recognition. So right now people are able to live transcribe something close to 70 different languages and dialects, so which is pretty incredible. Another cool feature that is coming to phones is the option to live caption. So now what you can do is just with a single click on your phone, you can turn on live captioning for not just your videos and podcasts, but your live stream from a camera. So for example, if I am literally just pointing a camera at one of you when you're speaking, I can bring in live captioning directly on the device. So, which is pretty incredible for people who have challenges with respect to hearing. It's pretty amazing what people can do right now with this kind of tech. Live relay is also something that that helps people with who have hearing impairments. So what you can do is essentially turn on this functionality where if you receive a call, you can just communicate in the form of text. So whatever your caller is speaking will be transcribed into text. And additionally, whatever you are typing in as a reply will be converted from text to speech. So again, all of this runs directly on the device, and you are not consuming a ton of power while doing that. Another project that I really, really liked was Project Euphonium. I'm just going to play the video. You can see why this was incredibly cool.
Genre of speech recognition, but if you do not stand as most of people, it will not understand you.
No one's ever collected large data sets of people whose speech is hard for others to understand.
People who have multiple sclerosis, for GF, who have stroke, who stutter.
They're not used in training the speech recognition models. The game is to record things and then have it recognize things that you say that aren't in the training set. Dimitri recorded 15,000 phrases. It wasn't obvious that this was going to work. He just sat there and kept recording.
We need to make all voice interactive devices be able to understand any person who speaks to them.
Yeah. Did you think it was incredible? So this is what one person who's right now at Google AI, so he's a researcher working with them, he recorded his own voice that, he has a speech impairment, and he was able to get a machine learning model to work despite his speech impairments. right? So Google is now seeking volunteers to send in voice recordings of themselves. So if you or anyone you know has a speech impairment and would like to benefit from a tech like this, please do send in, I think there's a link. I will include that link before we send out the slides to all of you. And so you can just go onto that link and sign up to submit your speech recordings. All right. Okay. And there were also a bunch of updates from Google AI Research, so ranging from computer vision to robotics integrated with computer vision. There are a bunch of really amazing things happening. So this was the talk by Jeff Dean that Margaret was talking about. So you can just go check out all the different things that he has to say about what's happening at Google AI. There are more updates, not just these. So these are just some of my favorite highlights that came out of that talk, because obviously I am a little bit biased towards healthcare. So the two cool things that Google currently is working on is one, diabetic retinopathy. So if you've attended TensorFlow talks before, you've definitely heard of this project. So in India, where I come from, we have a shortage of 127,000 doctors who can help with diagnoses for figuring out whether somebody's suffering from diabetic retinopathy. But then what ends up happening is 45% of the people end up either having partial blindness or complete blindness even before they go in for diagnosis. This is because, again, like I mentioned, 127,000 doctors in shortage, right? So what Google is doing is building this machine learning model that would help predict what is the risk of somebody, facing partial or full blindness. So they have a scoring of 1 to 5, and the machine learning model basically looks at the imaging data and classifies what your risk level is. So this way they can kind of speed up the process of diagnosis before it's too late. They're also currently getting into lung cancer prediction. It's a very new project. They just published a paper in Nature. So if anyone's interested, let me know, and I can send you a link to that. And then BERT is, for those of you in NLP, you probably heard of it. It is helping with pre-training your natural language processing projects. So that's another cool thing to check out if you haven't already heard of it. And then there's something called neural architecture search, which is essentially a meta search. So you're trying to figure out what is a good architecture for your particular problem. So obviously, we know that it's a lot of work trying to figure out what a good architecture is for our problem. But what you can do with neural architecture search is try and match different discrete components and figure out what is the best architecture that works for your particular problem. This has been deployed onto cloud. So for those of you who are working with cloud platforms, you can check out AutoML Vision, AutoML Speech, AutoML Text, and so on. So this is already publicly available. And now we also have Cloud TPU version 3, so that's a part of the TPU pod. This thing, I think, consists of 8 different blocks of this size, and you currently can make use of this. I think it's in beta still, but if you go to Google Cloud Platform, you will be able to access this and just see how quickly this works. So you can currently train a ResNet 50 model on the ImageNet dataset in less than 2 minutes when you're using the Cloud TPU version 3 pod. So that's just, to have a rough reference of how quickly this works. So another cool thing that we heard from is the Google AI Impact Challenge that basically happened. So Google, this is a part of the Google AI's AI for Social Good project. They had 2,602 applications come in, and they picked out 20 different winners. And we had the opportunity to meet some of these people at I/O. And one project was Talking Points, which essentially connects parents who are not able to communicate with their teachers in English. So for example, if I speak in a certain language, but my teacher only communicates in English, Talking Points is a messaging app that translates between the teacher and the parent. So that way, despite the language barrier, you can still communicate with each other, because obviously both of you are still looking to see what benefits the child most, right? So Talking Points is one of the winners of the Google AI Impact Challenge. Wadhwani AI is from India. What they're trying to do is essentially help out farmers figure out, if their crops are affected by pests through computer vision. And the last project here is, I cannot pronounce that to save my life. It's a project from France. It's essentially their version of Doctors Without Borders. So what they're trying to do is figure out what my resistance level is to a certain bacterial infection. The problem is, in a lot of low resource countries, what ends up happening is, despite the equipment being available, the staff are not trained enough to read and figure out if someone is having resistance to a certain type of antibacterial medication. So antibiotic medication, I'm so sorry. But what you can do is now make use of computer vision, take a picture of this tool that they make use of, and essentially communicate with the staff if someone has some type of a resistance. Because obviously the last thing you want to do is give them an antibiotic that you think is going to work, but your patient has a resistance and it's not going to have any effect on them, right? So Doctors Without Borders from France is looking to kind of overcome that problem in low resource countries. So for those of you who kind of want to get started in machine learning, TensorFlow 2.0 is a fantastic place to start. It is easy to use. It's super beginner friendly. If you've tried out PyTorch, I'm probably not supposed to say this in Google, but it kind of works in a similar fashion now because it is eager execution by default. So you can debug very easily, as opposed to when you were working with TensorFlow 1.x, when you have to create a session and then wait until all your variables are initialized, and then when you call session.run, then things happen, even to add a plus b, right? So all of that is gone with TensorFlow 2.0. Do check it out. There's a free course that you can get started with. There's one on Udacity and there's one on Coursera. For those of you who are already working with TensorFlow 1.x, it's pretty easy to upgrade. There are a couple of resources that I've listed out there. We've seen TensorFlow growing from 2015 when it was made open source. Now what they're doing with TensorFlow 2.0 is essentially bringing all of this together and neatly packaging right from training all the way through deployment for users and developers to essentially get started with it. They are also trying to be more transparent. So there's a TensorFlow 2.0 roadmap that they are publicly making available, so we can track what's happening with 2.0 continuously. And hopefully 2.0 should be made public by the end of this year. So this is the other talk that Margaret was mentioning, cutting edge TensorFlow. So Keras Tuner, for those of you who have tuned machine learning models, you know how much of a pain hyperparameter tuning is. So Keras Tuner is essentially a way that would help you make that a little more easier. Probabilistic programming is essentially a toolbox for probabilistic modeling. So now what you can do is take your probabilistic models and combine them with deep learning models on CPUs and GPUs, on basically any kind of hardware that you're currently making use of. So the thing with this is now you can bring in expert knowledge. So if I am a domain expert of some sort, I can bring in that information by modeling it and combine it with my deep learning models. So that's something that's coming with TensorFlow probability. And TensorFlow ranking, for those of you who work with click optimization and things like that, when you're trying to rank, so TensorFlow ranking kind of allows you to do that more intuitively, and it's pretty helpful that way. Another thing that is extremely exciting for me, because I used to work in computer graphics and I've now transitioned to computer vision, is this TensorFlow graphics. So what you can now do is essentially, what you're trying to do with computer vision is take an image and predict different scene parameters from that. So, what is the texture of a certain object? What is the pose of a certain object? And things like that, right? And if you're going into graphics, you have this information and you're trying to simulate it in a graphical environment, and you're trying to synthetically create that environment. So what you can do with TensorFlow graphics is essentially take in your image and bring out your model parameters. Now, when you recreate it using TensorFlow graphics, what you can do is essentially compare and see if what you get is what you wanted, right? If the synthetically generated model is the same as what you see in your input image. So it essentially works like an autoencoder if you think about it. So yeah, so that is the latest development, and it's now publicly available, so you can check it out at TensorFlow graphics. Another thing that they basically were talking about was human-centered AI. So for those of you who know about PAIR at Google, so it's the People Plus AI Research Program, so they've released a guidebook that you guys can check out. So these are essentially recommendations when you're trying to develop a model, right from you're figuring out what your user needs are and what your specs are going to be, all the way through like how do you measure success, and like if there are errors and if I fail, how do I deal with it. Another cool thing that came out of Google, this is something they've been working on at least from 2017. So it's called Federated Learning. So for those of you who are privacy nuts, pretty much like I am, this is a pretty cool deal. So what they're going to do is essentially, instead of transferring all of your data to the cloud and then figuring out how exactly your model should be updated, they are going to have some amount of training happen directly on board your device itself, but they're only going to send the updates to your local model to update the global model that they have. So that way what they do is they're only transferring in a very secure fashion the changes that happen to your local models, and not communicating the data that that is specific to each one of your users directly to the cloud. So federated learning is a term that Google has come up with, and what that allows you to do is essentially like build a global model without like letting go of any of your users' data and tailoring it to a certain set of users specifically. So yeah, and there are a bunch of other talks of interest. I know I had to rush through it because like we are literally out of time, but then there's a lot that happened at Google I/O, and like Margaret mentioned, there's an entire channel on Google developers on YouTube that talks about all the I/O, that lists all the I/O talks, and in the TensorFlow channel that lists all the I/O talks specific to TensorFlow. So if you're looking for ML talks, go to the TensorFlow channel. If you're looking for more general I/O talks, go to Google developers YouTube channel. So yeah, and the other cool thing, like Margaret mentioned, I/O is not just about sitting in sessions and just listening to all that they have to throw at us, but it is all about meeting people and trying out the cool sandbox experiments they have and the code labs that they have to offer. So right now, I don't think the hardware-related code labs are going to be accessible for us, but then there are a lot of other code labs related to machine learning that you guys can try out at that link specifically there. So to wrap up, Margaret showed you a specific video where she used dance-like. This is what they released to show more generally what dance-like looks like. And this, I think, was my most favorite sandbox experiment.
Dance-like enables you to learn how to dance on a mobile phone.
TensorFlow can take our smartphone camera and turn it into a powerful tool for analyzing body pose.
We had a team at Google that had developed an advanced model for doing pose segmentation, so we were able to take their implementation, convert it into TensorFlow Lite. Once we had it there, we could use it directly.
To run all the AI and machine learning models to detect body parts, it's a very computationally expensive process where we need to use the on-device GPUs. TensorFlow library made it possible so that we can leverage all these resources, the compute on the device, and give a great user experience.
Teaching people to dance is just the tip of the iceberg. Anything that involves movement would be a great candidate.
And so that means people who have skills can teach other people those skills. And AI is just this layer that really just interfaces between the two things. When you empower people to teach people, I think that's really when you have something that is game-changing.
Great, and that is pretty much
on a mobile phone.
TensorFlow. That's pretty much all I have for you guys. Thank you so much.
Thank you. Thank you so much, Navy, for your talk. And I thought that was a great transition, from my talk to hers. My talk was more of the high-level overview, and she went into great details, more thorough. information. So I want to thank you all for coming. And before you leave, I just want to share with you the upcoming GDG events. We are cross-posting one for the Google Cloud AI Huddle on May 30th I think it's in this room, for Empower Google Cloud Functions with ML. And then on June 8th, Andy and I are running a computer vision workshop. This computer vision workshop is not for beginners. It's more intermediate or advanced computer vision workshop. And then on September 21st, that's our day for DevFest Seattle. We don't have the event site yet, just so for those of you who are interested, you can mark your calendar now. Another upcoming event is Kotlin Everywhere. We haven't decided yet, either in the summer or in the fall, right, Inchi? So, and that's it. I would like to thank everyone, all the speakers and GDG organizers and Googler volunteers, and thank you all for coming, and see you soon at our next event. Oh, and Balaji's in the back with the Edge TPU if you want to take a very quick look.